Okay, go. So this talk is not actually specific for C++, but what you're gonna do? Stand up and leave? Well, I don't think so. So let's go on. This is a little story for you for starter. It was a beautiful morning in the office when I checked out my email and found out that most of our tests for the latest nightly build was failed. And I was like, what? What's going on? And I quickly found out the commit that was causing the troubles, and it turned out that there is an open code review for this commit. Take a look on it. It's actually a legendary review in our company. It contains 94 files. It has 94 files. It has 1,000 of reviewers, 169 comments, 26 hours spent reviewing, and a beautiful title which mentions bug fixing, improvements, and big changes. So it is like, what? Very impressive. So we know that's not how you do changes, right? So I'm just going to clarify why and what to do instead. So imagine you're changing the behavior of your little tiny lovely function, which changes the behavior of a class using this function. We change the behavior of a library using this class. We change the behavior of application using this library. We change the behavior of the user who uses your application. We change the business process built on top of this user. So what you can see here is the impact of your single change. And the impact is the risk, and the risk is the probability of you introducing a bug. While for the sake of this talk, to make things more dramatic and to clarify its meaning, let's say that if you introduce a bug, you die. So you want to avoid both of these things like equally, right? So what happened? You made a change which is observable on each level of that hierarchy. So this change actually has an unlimited impact. This is a functional change. Well, if you made a change that is observable only on several lower levels of that hierarchy, it has limited impact, and this is a refactoring change. And the risk for functional change is much more than the risk for refactoring change. Now, let's use this information on this graph. Graphs are awesome, right? So on x-axis, you have lines of code touched, and on y-axis, you have the probability of being dead after touching this line of code. So now let's place our review from the example on this graph. You're dead, right? That's not what you're going to be doing. First, what you need to do is to do a preliminary refactoring, which touches many lines of code, but which is less risky. And after you're ready, you actually do your risky change, but which touching much less lines of code. And in this case, hopefully, you will survive. Well, tests. You might, I have tests. I'm not afraid of touching my code, right? Wrong. First of all, tests failed, okay? But if you touched many lines of code, what exactly did you do wrong? Where exactly is your mistake? Not every test can help you with that. Then you never have 100% coverage, right? And finally, it's much easier to check that nothing has changed than to check that the change that was made are actually correct. That's why it is much easier to write tests for refactoring, because with refactoring you change nothing. So in a nutshell, when you're going to fix a bug, first of all, refactor your code in such a way that the bug is obvious and easy to fix, and only after that, fix it with as little changes as possible. If you're going to implement a new feature, first refactor your current architecture in such a way that feature fits smoothly in this new architecture, and only after that, implement your feature with as little changes as possible. And of course, don't forget to separate those into several commits. Speaking of commits, I recommend to each commit to have a particular kind of change, and these changes are actually clarifications of changes with limited and unlimited impact that we were talking about. And I recommend each kind of change to be marked with its own mark. You place this mark in the commit comment, and if you look at something like git log, you immediately realize what you are looking at. And these kinds of changes, they map smoothly on same versioning, and last but not the least, they require different attention from the reviewer. And attention of reviewers is a precious resource, and usually you want to spare that. So, refactoring is great. Preliminary refactoring is even better. Do refactoring, be a nice guy, just like this one.